Hello everyone, and welcome to this video. Today, I'm going to show you a mini simulation model created in AnyLogic that demonstrates a simple yet dynamic robot-based logistics system. Let's start with the basic idea. In a special zone called Boxes Appear, boxes are generated one by one, and each box is randomly assigned a color, yellow, blue, or red. Each color corresponds to a specific destination in the system. Yellow boxes go to destination 1 yellow circle. Blue boxes go to destination 2 blue circle. And red boxes go to destination 3 red circle. Now, the goal is simple. Robots need to identify the color of each box and deliver it to the correct destination. To build this simulation, we use two types of agents. The robot agent, which picks up and delivers the boxes, and the box agent, which contains the color information used to determine the delivery destination. Hammer and wrench resources and logic. The main resource in the system is the robot. The number of robots is parameterizable, meaning you can add or remove robots during the simulation, even in real time. Each robot picks up a box from the Boxes Appear zone as soon as it's available. Importantly, a new box appears only after the previous one is picked up, which helps control the flow. The color of each box is randomly assigned using a uniform distribution from a predefined list of colors. Once a robot has a box, it delivers it to the matching destination based on the box's color. World Map Layout Overview. The model includes a path network that allows robots to move efficiently without collisions. Destinations are placed at fixed positions. Yellow on the left, blue in the center, red on the right. Eyes available views. To make the experience more immersive and allow for better analysis, the model includes several visualization options: a classic 2D view of the system, a realistic 3D view, a process logic view that shows how the system operates step by step, and a KPI dashboard to track robot usage and overall performance. This simple but flexible model is a great foundation to explore logistic strategies, resource utilization, and system behavior under different conditions. All right, let's now start the simulation of this mini model. On the screen, we can see the different interfaces, the logic view, the 2D view, the 3D view, and the KPIs that are being tracked during simulation. In the 3D view, we can launch the animation by clicking the Start button. We clearly see the two robots, called forklifts in this context, each picking up a box and delivering it to a destination based on the box's color. We also have the option to speed up the simulation if needed. Switching to the 2D view, we can follow the movement of the robots along predefined paths. It's also possible to add more robots in real time, for example, a third or a fourth, and they will automatically join the operation. When there are no more boxes available, the robots go back to their parking spots, and each time a box is delivered, a new one appears in the zone, ready to be picked up by another robot. On the KPI side, we can track different robot states and the time spent in each activity: delivery, processing, go to parking, and moving toward the box. We're using two main data structures here: a list randomly filled with colors, and a dictionary, which links each color to a node, basically the delivery destination. Both are initialized at the start of the simulation. At any point, we can pause the simulation and dive into the code to understand the logic and tricks used to get this result. I'll give you a moment to explore the implementation, especially the code behind each AnyLogic block, and feel free to leave a comment if you have any questions. And now, we're reaching the end of the simulation. In this video, we covered introduction of a simple model with box delivery based on color, configuration of the number of robots, views, 2D, 3D logic, and global KPIs. In the next video, we will explore Video 2, Robot Control and Advanced Analysis with KPIs per robot title, dispatching boxes by rules and tracking robot performance, KPIs per robot in AnyLogic, content, use of custom functions for transporter choice and dispatching policy, adding individual KPIs for each robot, distance traveled, idle time, number of deliveries, and an explanation of how these KPIs help with system optimization. Thanks for watching. Don't hesitate to leave a comment with topics you'd like us to explore next in this area.